Okay, here's your video for the free response exam. Just remember, you have to be able to explain this stuff to me. So not just read it off your paper, not just memorize it, but really understand it and be able to explain it. All right, 9 sales representatives going on a trip, 6 men, 3 women. There were only enough to send 3. The manager selected 3 people to attend and stated that the people were selected at random. The 3 people were women. There is concerns that no men were selected to attend. He probably just wanted to save on a hotel bill. Let those women shack up together. But what do I know? All right, calculate the probability that selecting 3 people from a group will result in 3 women. If you did this wrong, it was because you just did, hey, there's 1/3 women, 1/3, 1/3, 1/3. But you have to remember these are people. So think about it as like Mary, Sarah, and Jane. You can't just do 1/3, 1/3, 1/3 because that could be Mary, Mary, and Mary. Mary can't go 3 times. It has to be all 3 different women. So the probability changes each time because it is without replacement. So for the first time, you're right. There's 3 women out of 9 that were selected. Then I selected somebody. So now I only have 8 left in the pool and only 2 of them are women. Then I only have 7 left and there was only 1 woman. So the probability of that is actually 0.012 or 1.2%. Okay, we have to remember, stop and take a minute to think about the situation. These are people going on a trip, so has to be without replacement. Okay, so based on your answer, is there reason to doubt the manager's claim that they were selected at random? So to get an E on this one, you had to say yes and why you said yes. So always with an explanation. So yes, there's reason to doubt, blah, 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 blah. Because 1.2% or 0.012, however you want to say it, is a low probability. And you'd want to write that all the way out in a sentence. But if you just said yes, or even if you just said it's a low probability, you have to have both. Just remember that you're trying to explain to somebody how much you actually know. So don't take shortcuts on this, okay? You have to say it's a low probability, it's a small probability, something like that. Therefore, there is reason to doubt, okay? And make sure you make a claim. Like, don't wiffle waffle. Yes, there's a reason to doubt, but it's still possible, so it could happen. You didn't get points off on this one, but I have seen points taken off for that before. So just make a reason and go for it, okay? Let's look at it. All right, C was a bit confusing to people, especially if you didn't get that A was done without replacement, then C was kind of near impossible. So it's saying, hey, let's use the dice to do this. So if you just did 1/3 cubed for A, then you probably thought that the dice simulation would work. But the reason that it does not work is because it's with a die, and you had to say no. Then you had to say that the dice would be simulating without replacement because the probabilities don't change with that one. It is a 1/3 chance of getting that over and over and over again without replacement. But the actual situation, I'm sorry, I just said that exactly backwards. The dice would be with replacement because it's like I don't take the 2 side off the dice and change the probability. The 2 is always there. Even I could select 2, 2, 2, and that would not be fair. But the situation is done without replacement. Since Mary can't be selected to go twice, it changes the probabilities as I continue to calculate. Therefore, the dice is not a good simulator for this situation. So there had to be 3 components to this to get it all the way right. You had to say no, make a decision, and you had to comment on both the dice and the situation. You could have either said, this is independent probabilities, the dice, whereas the situation is dependent. My probabilities change depending on if I chose a man or a woman. Or you could talk about with replacement and without the replacement. Or you could talk about the probabilities remain constant for the dice, whereas they change for the situation. Any of that would have worked, but you had to have all 3 criteria. Say no, talk about why the dice doesn't work, and talk about the situation. Okay. I just wrote all of this and explained it so beautifully, and then looked down and the record button wasn't even pressed. So, I'm awesome. Okay, so as I read, I underlined normal distribution, mean of 840, standard deviation 7.9. list that stuff out. They are looking for you to do that. That was actually a check mark on the list. For this one, you didn't get points off if you didn't do that because you could verify that you knew what you were talking about by showing your work for the Z-score. But if you didn't show either one of these, you didn't get credit for that. So they wanted to say, do you know that you're using a normal model with these two criteria? Then, did you find the appropriate Z-score? So actually writing down your Z-score was a check mark, and then finding the appropriate probability was the third check. You had to have all three of those criteria. So I wanted to find the probability that was more than 850 grams. So I put that in my formula for Z-score. The value I want minus the mean divided by the standard deviation. And that gave me a Z-score of 1.27. So when I drew my picture, remember you always put the mean in the middle. And then I'm looking at 850, but I want to know more than 850, so that's why I shaded over here. I used my calculator, so I put normal. Always CDF for normal. It's never PDF for normal. I don't want to know what's the probability I get exactly 850. I want 850 or more. So that's from this Z-score all the way to the end of time. And I would have got 0.1020. And you can either leave it like that or you can put it as a percentage. It doesn't matter. So to get an E on this one, you had to either write this or show your work for the normal model. Either one of the, or for the Z-score rather. You had to get the correct Z-score and you had to get the correct percentage out of that Z-score. Okay, so we have expected value, mean, and standard deviation of random variables again here. Remember, mean is very easy. You just do exactly what they say. So they're telling you that one carton is a expected mean of about 20, and each egg is 1.7 grams. So remember up top, we still have the information for the whole thing all together. The carton and the eggs all together had a expected value of 840. So now I'm trying to use the total and work all the way backwards. So if I know that it has a total of 840, well, I'm going to subtract out the carton, which is going to leave me at 820 for the eggs, and that's for all 12 eggs. So then I would divide by 12, and I would get 68.33 grams per egg. Now, a lot of you got the 68, but if you didn't show what you did, you only got partial credit. So remember, on the multiple choice, you can write not a stinking thing down, get the right answer, and everybody's happy. But on free response, you're supposed to be showing people you know how to do the math. So show them how to do it for the love of Jesus, okay? Because if you only wrote 68.33, you got partial credit. Even though I know you did it right, I still can't give you the full thing. So start writing it. Okay, standard deviation is where we kind of went wrong because we're given the stuff as variation. We're trying to get back to standard deviation, so standard deviation is just always harder. But here's how you have to think about it. So the variation of the entire thing would be equal to the variation of the carton plus 12 times the variation of one egg. Because how do you get the whole carton? Well, you get the, how do you get the whole thing all together? Well, you add the empty carton plus 12 times each of the eggs. Okay? So now, but I'm given stuff in standard deviation. So what I'm going to have to do here is square that stuff. So this is going to be the 7.9 for the standard deviation of the cart, but I have to square it to get it to variance. Here, I've got that, but I have to square it to get it into variance. Remember the rule, square it, do what you need to do, and then re-square root it. So that's what I'm doing here, and that would be equal to, I already know this too. Hey, sorry, I was writing in the wrong order. I was confused on what W, all that. So I'm just going to start over. Okay, so what we want to do is we want to have the variance of the whole carton is equal to the variance with the eggs, what I mean whole, is the variance to just the carton by itself plus 12 times the variance of each egg. Okay, so the whole thing all put together should be the empty cart plus 12 times the eggs. So the 7.9, that's from the very top. I can't see the very top of my paper right now, so I got all my numbers mixed up. 7.9 is the standard deviation of the whole thing, carton and eggs all put together. So since I want it in variance, I square it. 1.7 is the variance of the empty cart, so I square it for that, plus 12 times the variance of each egg. That is what I'm solving for. So now I have an equation that I can solve for x. So I have this, when you square it, is 62.41 equals 2.89 plus 12 times the variance of the egg. Okay, then I'm going to subtract the 2.89. Okay, and I'm going to get 59.52 is equal to 12 times the variance of each egg. Okay, divide by 12. So that works out to be 4.96 is equal to the variance of each egg. Well, the question doesn't ask for variance, it asks for standard deviation. So I have to go back and square root it to get the standard deviation, would be 2.23. Okay, so remember the rules. Square it, do what you need to do, and then square root it at the end. So that's what I did. I took all the standard deviations that I knew, I squared them, then I solved for x. Move the empty cart over, subtract the empty cart by itself, divide by 12 since there are 12 eggs. That gives me the variance of an egg, square root it to get it back into standard deviation. Okay, airline claims that there is a probability of 10% that a coach class ticket holder who flies frequently would be upgraded to first class on any flight. The outcome is independent from flight to flight. Sam is a frequent flyer who always purchases coach class tickets. What is the probability that his first upgrade, right there, first upgrade, that tells me I am going to do geometric, will occur after the third flight. So after tells me that I'm probably going to be doing CDF because I'm going to have multiple possibilities. And the third flight, so the key that I'm looking for is the 3. You have to define your variables. If you don't, and you don't write down your calculator speak, even if you get the right probability, you're only getting partial. So after the third flight, well, what does that mean? That means it could be the 4th flight or the 5th flight or the 6th flight, on and on and on. So that's what I want, is from 4 up. Remember, your calculator doesn't do up. So you can't do that. So you can't say, hey, let me type in what I want. You have to type in what do I don't want? Well, I don't want it to be 1 or 2 or 3. So I'm going to do 1 minus the probability of getting it on 3 or fewer. I want 4, 5, and 6, so I don't want 1, 2, and 3. So I do 1 minus 1, 2, and 3. You have to label what P and X is. If you don't, you're sitting at a partial credit. When I type that in my calculator, I get 7.729. What is the probability that Sam will be upgraded exactly 2 times in his next 20 flights? So exactly, well, multiple successes tells me that that's going to be binomial. Exactly tells me that that's going to be PDF. Okay? I have 20 tries. My probability is still 0.1, and I am trying to get 2 out of 20. So binomial PDF, oopsies, 2. When you type that in, then you get 0.2852. Okay, you must label. You can either label here, or you can label right on top of there, just so they know you know what you're doing and you're not just a lucky button pusher. All right. If Sam takes 104 flights in the next year, my probability is still 0.1. Heaven mercy. Would you be surprised if Sam receives more than 20 flights? So we're trying to do greater than 20. So you can either do binomial for this, or you could do normal model because it's large enough. It doesn't matter. Either one will work. Since we've already done binomial, I'll just leave it at binomial. So let's find the probability he's going to get more than, I want 20 or 21 all the way up to 104. Well, I can't do that on mine. I have to do, what do I don't want? Well, I don't want 1 through 19. Okay, so let me find 1 minus. We already said it's going to be binomial because I need multiple successes. CDF because it's a range, 20 to 104. There's 104 trials with a probability of 0.1, and I want 20 or more. When I type all that in, I get 0.0014, or a 0.14% chance. So then I would want to answer the question. Yes, I would be surprised because it's a very low probability. Just like you did on question number 1, you have to have both. Make a decision and tie your decision to your math. Okay? One of the things that several of you did, and I actually think is a good plan, was to find the expected outcome. Well, if he's only going to get upgraded 10% of the time, and he takes 104 flights, he should only get about 10 upgrades. So if he got 20, I would be surprised. That's more than double. That's a very good thought process, and it's a good explanation. But that only got you partial credit because they really want to test your probability on this one. So if you take a shorter cut math, you're gonna get the same thing, and I'm right there with you, standing strong, but you didn't find an exact probability that would happen, so you kind of just skirted around the answer. So just try to be as thorough and exact as possible.